Hey everyone, welcome back to my number sense series. In this video, we're going to talk about the divisibility rules for 3 and 9. And I think these are the coolest divisibility rules that we have because they are really simple. I'll tell you what they are right now. For 3 and 9, all you have to do is add up the digits to determine if it's divisible by 3. For any number, simply add up all the digits, and then if the number that you get is divisible by 3, then so is the original number. But why? Does it work like that? Well, let's reason through it with a random number like, I don't know, like 78536. We want to know if this number is divisible by 3, but it would be kind of inefficient to just start actually dividing by 3. So to develop a trick, we have to look at another concept, which is place value. The value of this place is 7 times 10,000. The value of this is 8 times 1,000. The value of this is 5 times 100. Then we have 3 times 10 and 6. Now, 10,000, 1,000, 110, what do they all have in common? They all have remainder 1 when divided by 3. In other words, we can kind of think of 10,000 as 9999 plus 1. Think of 1,000 as 999 plus 1. So this is 7 times 999 plus 1, 999 plus 1, 5 times 99 plus 1, 3 times 9 plus 1, and then just 6. And here is the interesting thing, because if we have something that is a multiple of 3, and then we add or subtract another multiple of 3, the fact that it's a multiple of 3 does not change. And in fact, we can generalize this to say that the remainder will not change. If I have some number, and then I subtract from it or add to it a multiple of 3, the remainder of the number when you divide it by 3 does not change. And we call this a modulus, or a mod for short. But we won't get into that concept today. That's just terminology. So 7 times 9999 plus 1, if we expand this using the distributive property, this is 7 times 9999 plus 7 times 1, which is equal to, this is just 7. But 7 times 9999, that's a multiple of 3, because 9999 is a multiple of 3. So if we subtract this from our original number, the remainder of this number, when you divide it by 3, should not change. So we can just subtract it, because we know it doesn't actually change anything. And similarly, we can get rid of this and this and this. We can get rid of all the 9s, and that leaves us with just 1s. Specifically, it's 7 plus 8 plus 5 plus 3 plus 6. And this is where the trick comes from. Now, if you add up everything here, what you get is 29. And 29, now you ask yourself, is 29 divisible by 3? The answer is, of course, no. So we know that this number is not divisible by 3. But this goes even further, because we can actually just find out the remainder from this. Because, according to the same logic, the remainder is preserved here. So 29 will have the same remainder when you divide it by 3 as 78536. And 29 has a remainder of 2, so we know that this number also has a remainder of 2 when you divide it by 3. And now a final trick that we like to use when we do this kind of stuff is to actually get rid of digits before we add them. Because single digit addition, it's very easy, but it still takes some amount of time. And so we're trying to cut down any time that we possibly can when we do number sense. So we can use the same principle that we use here, subtract things that are multiples of 3 in order to cut down on our addition. Because if we notice, we have 3 and 6 right here. 3 and 6, those are already multiples of 3. So we don't even need to count them because they won't change the final answer. Similarly, if we want to, we can also notice that 7 plus 8 is 15. And 15 is a multiple of 3, so we can cross out 7 and 8. And this part is kind of optional, but if you are able to see this very quickly in contests, and you're able to keep track of which numbers you're getting rid of in your summation, this can be very helpful. And so if we do all of that, we're actually just left with 5. And 5, of course, does have the same remainder as these, which is 2 mod 3. It has a remainder of 2 when divided by 3, 2 mod 3. So that is our proof for the trick. And now let's just do a little bit of practice. Suppose we have 1434, And we want to find the remainder of 1434 when we divide it by 3, or we want to tell if 1434 is divisible by 3. Really, they're kind of the same question because divisible by 3 is just a way of saying remainder 0. So to find the remainder of this number when we divide it by 3, all we have to do is add the digits up. And of course, when we see this, we should also notice that there's a 3 here, so we can just get rid of it. So what we're doing is doing 1 plus 4, which is 9, and everyone knows 9 equals 3 times 3, so it's a multiple of 3. Remainder 0, or you could say 0 mod 3. It has a remainder of 0 when you divide it by 3. This number is 0 mod 3. Also, you would write this, but yeah. Now, a bigger number, 665348. But of course, with this trick, bigger numbers should not make you scared at all, because all it really is doing is adding more one-digit addition, which is super easy. And also notice here that we have even more multiples of 3 in the digits. 6 is a multiple of 3, and so is 3. So we're actually just doing 5 plus 4 plus 8. And also, wait a second, 5 plus 4 is 9. If you see this during contest, you can also just cancel that out. And so we're just left with 8. 8, remainder 2. Yep, that's it. So that is the divisibility rule for 3, and by generalization, the rule for telling what a number is, what the remainder of a number is when you divide it by 3. And now when we move on to 9, you'll see that this is actually a very, very similar idea. Because, just look at this proof actually. This proof works the exact same as it does for 9, because we have 7 times 9999 plus 1. We have 8, 5, 3, 6 times 999 plus 1 times 99 plus 1 times 9 plus 1 and 6. And if we think about it, 9 is also a divisor of 9999, which means 7 times 9999 is also going to be a multiple of 9. So following the same principle of subtraction, we can also just get rid of the 999 here when we're talking about 9s. Similarly, we can get rid of 999, 99, and also 9, and that leaves us with actually just the exact same trick, the sum of all the digits. Awesome, right? So let's do a little bit of practice here. Now, in our first number, you'll notice that there's actually nothing that's 9. Right? Because there's no multiple of 9 that's a digit except for 9. So we're not going to be doing anything like canceling the 6's here. But if you are familiar, if this kind of is how it works in your brain, for some people it does, for some people it doesn't. If this is how it kind of works in your brain and you see things, you can also just get rid of the 4 and 5 here. Because once again, 4 and 5 make 9. So we're actually just doing 5 plus 6 plus 2, which is 13. And so if this question was asking you, is this number divisible by 9? You would say nope, because 13 is not divisible by 9. And if it was asking you for the remainder when you divide this number by 9, you would say that it is 13 divided by 9, leaves remainder 4. Now, last question, just get a little bit of practice in. And also, if you see this question in contest, I would not just start adding digits because there are digits that you can cancel here. So always kind of at least scan the number for digits that you can cancel. Of course, it may not be worth that much time to do it if you are really good at just doing one digit addition, but every little bit counts, and I find that this does help me. So what I see here is 9, get out, 9 and 9, and also there's 3 3s. If this is hard for you to keep track of in your head, it's okay if you don't start canceling digits right away, but I find that this is a skill that I can develop, and it is really helpful. So kind of get used to imagining, visualizing these digits being crossed out in your head. So 9 gets rid, all these 3's are out. So all we have left is 1, 4, 2. So 1 plus 4 plus 2 equals 7. And so once again, if the question was, is this a multiple of 9? Is this number divisible by 9? The answer would be nope, because 7 equals not 0 or 9 or a multiple of 9. And also, if the question was, what's the remainder when you divide it by 9, you would say the remainder when you divide this number by 9 equals 7. So that is it for this video. I think this is honestly one of the coolest divisibility rules that we have. I would say this The other cool one is 11, which we're going to talk about in the next video. 11 actually has a very, very interesting proof, but we're not going to be able to do that until we understand a little bit more about how these numbers work. But for now, this is an awesome trick. Just remember, it's the sum of the digits, and then look at the sum of the digits and see if that's a multiple of 3 or 9. That's literally it, but also remember the derivation. And yeah, I hope this video was helpful. Thank you guys so much for watching, and I'll see you next time.